The next 3 videos will be about the 3 principal types of passive component: resistors, inductors and capacitors. We'll start off with resistors. We've already discussed how all materials have a resistance associated with them, and this determines how much voltage is necessary for a particular current to flow. The relationship is known as Ohm's law, V equals I times R. Well, the resistance causes energy to be dissipated as heat, so the wire gets hot due to its resistance. The power dissipated is given by P equals V squared over R, which is also equal to I squared R. Current and voltage go up and down together in a circuit with resistance, as you might expect. That is, they are in phase. Sometimes it's necessary to add extra resistance into a circuit, and we can do this by adding a special component called a resistor. This is made from a material with a high resistance, often a type of carbon, or for high-powered types, a high-resistance wire. Small resistors have coloured stripes on their body, and these indicate through a code their value in ohms, and also how accurate they are, which is called their tolerance. You can find out about this code by searching online for resistor colour code. The circuit symbol, called the schematic symbol for a resistor, is shown on the screen. Values of resistors are sometimes abbreviated as follows. 100 is equal to 100R is equal to 100 ohms. The symbol for ohms is the Greek letter omega, the last letter of the Greek alphabet. 1K2 is equal to 1.2 kiloohms, in other words 1200 ohms, and 1M2 is 1.2 megohms, is equal to 1.2 million ohms. So why might we want to add a resistor into a circuit in the first place? Well, there are 3 basic reasons, and I'll explain these one at a time. Firstly, to limit the current through a component. Sometimes, either because we need to have an exact current flowing, or because we need to protect a circuit or a component from excess current, which might cause it to overheat, for example, we put in extra resistance into the circuit. Here are a couple of examples. A light-emitting diode, or LED, is a small device, a type of diode which we'll cover later on in the course, which is designed to emit light. If we try and connect it straight to a battery, however, since it has very little resistance itself, we might end up burning it out. So a resistor is often put into the circuit to limit the current flowing through it. In the example below, to, for example, 5 milliamps. In actual fact, as we will learn later, the diode itself has a small voltage across it, but we don't need to worry about that right at the moment. Another example might be an electromagnet. As you may remember, it's just a coil of wire. If too much current passes through this, we might overheat the power supply or burn out the wires. So in this example, let's say that we want to limit the current to 1 amp flowing from a 10 volt power supply. We also need, however, to make sure that we choose a resistor which can handle this much power. In this case, the power flowing through the resistor is shown in the calculation on the screen and is equal to 10 watts. The second reason that we might use a resistor in a circuit is to convert a current into a voltage. Suppose, for example, we have a sensor which produces a varying current output according to what it's measuring. We could use a resistor to convert this current into a voltage. We might want to do this because voltages are generally easier to manipulate and to process in electronic circuits. You will see later on an important application of this principle when we discuss transistors. So in this example, let's say that we have a current which varied between 0 and 5 milliamps, and we can feed this into the 1K resistor, and this would produce a voltage which varied between 0 and 5 volts as the output. The third and final important application of resistors actually involves two of them and is called a potential divider. Its purpose is to generate a lower voltage from a higher one by dividing it up. For example, say we had two 1 kilo ohm resistors attached to a 10 volt battery as shown in the diagram. As an exercise, see if you can prove that this is the case from Ohm's law. Similarly, we can divide up any voltage by the ratio of the two resistors. Here's another couple of examples. The general formula for a voltage divider, so that you can work out any ratio you like, is shown below. Resistors are also available in adjustable or variable types, either with 3 terminals or with 2 terminals. As a general point, any component shown in a diagram with an arrow through it is a variable or adjustable component. Components which are designed only to be adjusted occasionally, which are sometimes called trimmers, have a slightly different symbol shown in the diagram. Variable resistors are very useful, for example, in the volume control of audio amplifiers or radios.